Wrong one. Okay, good morning. Today we are working on math packet number 12 for pre-algebra. This is our last math packet of the year. I know we're super sad about that. We're going to look at our pages to see some things that we can do to solve these pages. So our first page. In the first 3 games of the basketball season, Marvin made 12 out of 30 shots. In his next game, he took 10 shots and raised his season average to 50%. How many of the 10 shots did he make? The first thing I did was I looked at that and said, well, if he's raising his average to 50%, I need to know what percentage he was at when he had 12 out of 30. So I need to figure that percent out. And remember, to figure out that percentage, he had 12 shots made out of 30. So 12 divided by 30, and that gives me a 40%. So then I know that he takes 10 more shots. So now my denominator is going to be out of 40 shots. And I need to be at a percentage of 50%. So I need to look at that and say, I need to go from 12 out of 30, which was 40%. I need to jump up to 50%. I actually probably didn't even need to do that part, but that's where my brain went to first was, hey, I should know that. But I know that 12 out of 30 was 40%. I am now going to be out of 40 shots. I need to go to 50. What number do I need up here to go to 50%? What number did I have correct? What number do I need to be at? That will tell me how many shots he made correct. Next page. Raffle tickets for a school fundraiser were sold for $5 each by the school's 5th through 8th grade classes. 8th grade sold 20 more tickets than the 7th grade. 7th grade sold 4 more tickets than the 6th grade. 5th grade sold exactly half the number of tickets that the 8th grade sold. In all, $1,250 worth of tickets were sold. How many tickets did each grade sell? First thing I looked at was, I need to know tickets, and they're telling me dollars. So I need to convert my $1,250, $5 per ticket. How many tickets were sold altogether? So I need to do what, Emily? I need to divide 1,250 by my $5 to see how many tickets altogether were sold. Then I can break those tickets up into my grades. So I know I have 5th grade, 6th grade, 7th grade, and 8th grade. I like to use bar models because that's what I was teaching at my last school. We worked really hard with the bar models, so I always default to drawing a picture with my bar models. I've seen some people just doing the straight up math. That's totally fine. I go to the bar models to help explain the word problems. So with the bar models, I want to use equal units. So if I look at this, I know that the 8th grade sold 20 more tickets than the 7th grade. So 8th grade sold this many tickets, same amount as the 7th grade, but they sold 20 more than the 7th grade. 7th grade sold 4 more tickets than the 6th grade. So I look at that and say, okay, here's the 7th grade, 6th grade, they sold 4 more. 8th grade sold 20 more than the 7th grade. I need to make that plus 24. Because the 7th grade didn't just sell 1 unit, they sold the unit plus 4. So 8th grade sold a unit plus 24. Because they sold 20 more than the 7th grade. 6th grade sold their unit, and 5th grade sold exactly half the number of tickets that the 8th grade sold. So they had that half of a unit plus half of the 24 extras. Altogether, If I did $1,250 divided by 5, that gives me 250 tickets. So I need to break up my 250 tickets into those common units, half of a common unit. This one had plus 12, plus 4, plus 24. Oh my goodness, I have all those extras. I can subtract all those extras out to see how to break up my unit. So I'm going to do 12 plus 4, 16, 16 plus 24 is 40. So if I subtract 40 away, I know that my units are going to equal 210 tickets. So now I need to divide that 210. I need 3 equal units and then half of a unit. So I'm not going to solve it for you, but that is how I set it up. So I knew that I had 210 tickets that I needed to break up evenly amongst 3 of them, and then have half the amount for that 4th one. And then I'll put those numbers in, and if I had more tickets over here, I'll add those to it. So my answer is going to have 5th grade sold this much, 6th grade sold this much, 7th grade sold this much, and 8th grade sold this much. Yes?
When you say half, you divide so when you divide 210 divided by 3.
I'm not going to do 210 divided by 3 because that's going to be too big. Yeah, so you have to play around with it a little bit. It's not the most precise way of doing it. There is a little guess and checking. So if you divided it by 3, you'd get 70. And then you'd say, oh, wait, but I need to have some for the 5th grade. So I need to take some off of the 6th, 7th, and 8th grade. They're not going to be 70 each because I had to take some of those tickets to give it to 5th grade. So what number would these 3 grades go down to bring this up to be half of it? Evan?
So if you would add 8, 7th, and 6th, and then 5th, and then add 40, so it equals 7.
Correct. Okay, so there was a little bit of work you have to do with it. It's not simple. You have to play around with it a little bit to make sure that you get the correct numbers. This is just the way that my brain automatically went to, because like I said, I taught the bar models a lot, so I went to this. Everybody that's turned in their packet so far, they've come about it a slightly different way. So if you're not wanting to do the bar models, that's okay. That just gives us a stepping stone if you're not sure where to start at. Our next page is our 5-card challenge. You will notice on the 5-card challenge that there are 2 9s. So in your equations that you do, you can use the 9 twice. I've seen some really good actual 5-card challenges coming out where you use all 5 cards to equal the 5. Try to challenge yourself. Find at least one 5-card challenge. Then our next page is our pattern page. So we know Pre Algebra only has to go to that 5th figure. We do not have to do the full table. We have figure 1, figure 2, figure 3 is already there for us. So we just need to figure out the pattern for the 4th and the 5th figures. So let's fill in figures 1, 2, and 3. How many yellows are in figure 1?
1.
How many whites?
8.
How many reds?
16.
How many altogether?
25.
Let's look at figure 2. How many yellows?
4.
How many whites?
32.
How many reds?
62.
And how many total?
100.
Figure 3. How many yellows?
9.
How many whites? 72. How many reds? 144. And how many altogether? 225. Okay, so those three figures, we were just counting from our picture. Now, in order to do figure 4 and figure 5, we need to find our patterns. What are my favorite kind of numbers? Not square roots. Perfect squares. Perfect squares are my favorite. This one is chock full of perfect square patterns. Let's look at our yellows. What is the perfect square of what? 1. So 1 is 1 squared. What is 4? What is 9? Where are we getting our 1, 2, and 3? From our figure number. Can you figure out 4 and 5? Knowing that? Next easy one is our red. Thinking about my perfect squares. What is 16? 4 squared. What is 64? What is 144? See a pattern? 4 squared, 8 squared, 12 squared. Total squares. 25. 5 squared. 100. 10 squared. 225. What was it? 15 squared. Do you see a pattern there? If we know our yellow pattern, our red pattern, our total blocks pattern, can we figure out what the white should be? Yeah. Subtract out the red and the yellow, and you're left with the white from the total. Is there a pattern for the white? There sure is. There is. There's a pattern for all of them. Challenge yourself and see if you can find the pattern, because there is one. Okay? You don't need to know it to be able to fill in your table. But it's all about learning and growing with the math. So you can challenge yourself to figure it out. Next page is drawing our net. One thing we need to remember when we draw our net, if it is a rectangular prism, our net should not look like it's a cube opened up. Our top and our bottom are a different size than the sides. So when you draw that net, you draw your top, you've got your bottom, those are the same size, but then you're going to make it a little bit smaller for our sides. Okay, we shouldn't have 4 rectangles that are identical. Because when we fold it back together, the sides and the sides need to be the same length. So like our Kleenex box, you fold it up, they need to match up like a Kleenex box. So make sure that when you're drawing the net, you're trying to draw them to be the same size, the pieces that actually match up. Your top and your bottom should be the same size, so those measurements correspond correctly. So try hard to do that. Take note that pre-algebra is not just doing our net, we are also finding the surface area and the volume. So if you know that x equals 4, you know which numbers to put in each place. Remember surface area, you find the area of every shape in the net, you add them up. Volume of a rectangular prism, length times width times height. So remember, volume is length times width times height. Surface area means that we add all the areas of each shape. Next page is our volume page. So we need to know all of the formulas for the volume for each of these shapes. Same formulas we've been using, so you might remember them. Rectangular prism is length times width times height. A cube is the length times width times height. They need to all be the same. So you could write that it's side cubed. take note that it's 0.216. So make sure, oh, there's a decimal in your answer, because there's a decimal for the volume, right? Triangular prism, length times width times height divided by 2. The pyramid, length times width times height divided by 3. And if you want to challenge yourself, work with that pi. Cylinder is pi r squared times the height. The cone is pi r squared height divided by 3. And the sphere is 4/3 pi r cubed. Pre-algebra needs to do at least 3 of them. Challenge yourself. Maybe you're always doing the easy shapes on top. Maybe you might want to challenge yourself with on the bottom. Maybe you might want to challenge yourself by doing all of them. No, you can go back and look at the video if you didn't get the formulas. I will be posting this video, but we have more pages to get through before lunch. Next one, find the entire figure and shaded region. Figure WXYZ is a square, and the 3 smaller squares are congruent. So the 3 white squares are all the same size. If one side is 24, we know all the sides are 24. So the area of the figure, that is our full square. And then we need to know the area of the shaded. When I looked at this, I went, oh, I've got 3 whites, so I can break this side up into 3 sections. And they're all congruent, so they're the same size. So 24 broken up into 3 sections, I know that those sides are 8. That helps me figure out the area of my white squares. If I can figure out one side of one square, I know the sides of all of those white squares. I can do those 3 areas, subtract it out from my big square, and I am left with the shaded. Next page. This one, you gotta play around with it. A lot easier to start with a pencil and then color it in. Don't start with the color right away, because if you make a mistake, it's hard to erase that. Start with the pencil. Some people are just labeling it like P for purple, B for blue, G for green, and they're writing the letter on it, and then they go back and they color it in. But it's easy to erase that pencil letter. So using only 4 colors, you're going to color in the map where they don't share a common vertex. So here, if I did purple, green, red, and blue, because I couldn't put a red where we're going to be sharing a common vertex. So no 2 regions share a common edge, although 2 regions share the vertex, but nobody shares the common edge. So I couldn't put a purple here because there's a purple here and they share that edge. So make sure those sides don't overlap. Okay. Next page. We know how to do the polynomials. Last page is the Sudoku. So remember, in the box can only be 1, 2, 3, and 4. In the columns and rows, 1, 2, 3, 4. So make sure we don't have same numbers in a square, a column, or a row. With that, we are done with packet number 12. I hope you have a wonderful day.